Alright, welcome to part 2, and just to finish this one up, so we showed one way you could see if this triangle has a right angle or not. So one way is to compare the slopes to see if there are any negative reciprocals when you compare the slopes to each other. The other thing that could potentially work, this one might be a little bit easier because it's based on something you've already calculated, is if it was a right triangle, the Pythagorean theorem would have to be true. So if it was a right triangle, okay, that means that a squared plus b squared would have to equal c squared. What we can do, we can actually set it up and do it as a check. So we can split up into left side and right side and see if when we do a squared plus b squared, so the sum of the squares of the two smaller sides, see if it's going to be equal to the square of the larger side. So our two smaller sides here, if you take a look at our two distances here, are root 10 and root 10. So I'm going to put that in for a and b. So that's going to give me root 10 all squared plus another root 10 all squared. Okay, c is my hypotenuse, that's my longest side, that's AC over here, which I calculated that length to be square root of 20. Now, when I evaluate this here, the square root of 10 all squared, you can run through your calculator to prove it, but that's just going to be 10. So I'm going to get 10 plus 10 over here, and that's going to be equal to 20. Okay, now over here, square root of 20 all squared is also just 20. So what I'm seeing here is since left side equals right side, the Pythagorean theorem is true, which means we have a right angle. So triangle ABC is right. Okay, if you did this check and you saw that left side was not equal to right side, that would tell you that there is no right angle because the Pythagorean theorem wouldn't be true. And again, it's only true with right triangles. Okay, so in general, if I ask you to classify a triangle, I won't necessarily tell you to check if it's a right angle or not. You need to know on your own to check if it's scalene, isosceles, equilateral, and also check if there's a right angle as well. So now that we can do those two things, you're expected to do both of those if I ask you to classify any kind of triangle that I give you. Okay, let's take a look at one more example. This one's a bit of a thinker. So now we have a parking lot, and the closest power line to it runs along a straight line that contains the point 0, 4 and 18, 13. And we want to know at what point on the power line the cable from this lamp over here at 619 would be connected. And I'm trying to figure out how much cable would be needed. Again, what we're basically trying to do is trying to figure out the shortest way of running a power line from this lamp to this existing power line right here. So let's draw this line right here, in right there. So this is the line connecting, again, 0, 4, and 18, 13. And it's a power line, so you can picture it going on forever. Okay, and what we're trying to figure out here is how we get from, again, this lamp that's over here at L to this power line in the shortest distance possible. So if you think about how we could get to from L to this power line the shortest way possible, well, what's the fastest way? To walk straight at it. And if we're going to walk straight towards it here and connect this power line, we're going to be connecting with this power line at a 90-degree angle right here. Okay, so what I'm looking for right here is actually, let me just redraw this in here. I'm looking for this distance right here. And again, if I'm looking for the shortest distance there is to go from this lamp to this power line, trying to save as much money, they should connect at a 90-degree angle. Okay, so this is the distance I'm looking for. Now the only problem is to find this distance, I need actually 2 points. I need to find out where it starts over here at L, which I do have, but I also need to find this point right here where it meets the power line. And that point I don't know. I could try and estimate on the graph, but as we know, estimating isn't necessarily very accurate. So I have to somehow find that point. So just think for a second how you might go about doing this. We're trying to find a point of intersection between a line here and a line here. How do we find a point of intersection? We're going to go all the way back to the first unit in the course when we talked about solving systems of equations, points of intersection between two lines, and involved using substitution or elimination. So in order to do that, we have to actually find the equations of both of these lines. So what I'm going to first do is find the equation of the power line, which I'm going to call P. So you should be a pro at finding equations of lines since grade 9. But I'll run through this one with you together. So we need two things to find the equation of a line. We need the slope and we need a point. So to find the slope, we need 2 points. We have 2 points here, A and B. So let's calculate that first. The slope of AB will be 13 minus 4, y2 minus y1, over 18 minus 0, x2 minus x1. So I wind up with 13 minus 4 is 9 over 18, which is a slope of 1 over 2. Okay, now I have 2 points to choose from here. I'm going to choose to use this point A because it's very nice. It happens to be the y-intercept. So I can jump straight into slope-intercept form and say the equation of that power line is 1 over 2x plus 4. Okay, now that's the equation of my power line. I got to find the equation of this one right here. So the line going from L to some point of intersection, which we'll just call, I don't know, let's call it Q. So I need to find this equation right here. Now, the only problem is, again, to find the equation of a line, I need a slope and a point. I have a point, but I don't have enough information to find a slope because I need a second point for that. If I had a second point, I'd be okay. I would already know the point of intersection. But one thing I do know to help me find the slope is that this line right here, this LQ, is perpendicular to this power line, P. So if it's perpendicular, slopes are negative reciprocals of each other. So looking at the equation of my second line right here, so I'll make the note here, equation of LQ. Well, I know the slope is going to be perpendicular to my slope of 1 over 2, so that slope is going to be negative 2 over 1, or just negative 2. So once I have that slope, I have the point L over here. So I can jump straight into creating point slope form. So y would be equal to negative 2, bracket x minus 6 plus 19. And there you have it, my second line. So I'm trying to find where these two lines intersect. I'm looking for their point of intersection, so I can use substitution or elimination. So I'm going to use substitution because I already have y equals in both. So that means I'm going to take my y equals half x plus 4. Let me just copy it down here. And my y equals negative 2x minus 6 plus 19. Now, I'm told from the first equation here, if I'm going to use substitution, that y equals a half x plus 4. I'm going to replace that in the other equation. So that's going to give me half x plus 4 equals negative 2 x minus 6 plus 19. So once I do the substitution step, I only have one variable left, it's x. I'm going to leave the algebra to you to solve for x, so try it on your own and push play and ready to go through the answer together. Okay, so to check your answer here, I expanded and simplified and solved for x. So I brought all my x terms over to one side, brought all my constants to the other. When I simplify my fractions here, I got 5 over 2x equals 27. I multiplied both sides of the equation by 2 first to get 5x equals 54. So times 2 times 2. And then divided both sides of the equation by 5 to get 54 over 5. I then, if you remember, using substitution or elimination, I used one of my original equations to solve for my other variable. I put the x value in here, and then working through the fractions, I get 47 over 5. So my POI is 54 over 5, 47 over 5, or if you want to use decimals because they are exact in this case, you get 10.89.4. So again, what this gives me all the way up in this diagram right here is this point Q right here. So it's 10.89.4. So now I found the point where this cable from the lamp is going to be connected. I need to find that distance still. So one last step left. I need to find the distance between the point L, which is 619, and my intersection point at 10.89.4. So I'll bring that down here and do one last calculation here on distance. Pardon me. So d is equal to the square root. So x2 minus x1, I'm going to have 10.8 minus 6 squared plus, using my y values, y2 minus y1, 9.4 minus 19 squared. Okay, I'm going to leave this to you. Run this through your calculator, make sure you can get the right answer. Okay, and you should get approximately 10.73 units, but it said up here that each unit represented 1 meter, so this would be approximately 10.73 meters of cable to connect the lamp to the cable, the power line here, using the shortest distance possible. So this question brings in a lot. It brings in forming equations of lines, finding points of intersection, and finally using distance formulas. There's a lot that goes into this. They make really, really good application questions, and it's a good way to use distance formula as well and bring everything together. Okay, so that's it. Please make sure you practice the stuff in the homework, and we'll move on and do something new tomorrow. Okay, cheers.